So this is going to be a relatively quick video about horizontal and vertical lines and different types of information on them, like what's their slope or how how to calculate the slope, things like that. So first, let's get a horizontal line in here. I'm going to use my ruler to draw one, and we'll put it at, we'll say y equals 2. Okay, so if you watched my last video, you already know how to do things like find slope and y-intercept, which you can put in an equation just by looking at a graph or a table or points. So let's actually do that for this line right here. Now, like we said in that last video, the formula was m equals delta y over delta x, right? Now, if you look at this horizontal line, you'll notice that there really is no change in y because the line is not increasing at all. It's staying still. It's staying constant, staying static at one point on the graph, or like one how do I say this? One y coordinate on the graph, right? Now, let's take 2 points anyways and try to do this. So I'll use one right here, assuming we're going by intervals of 1. This is going to be 0, 2. And we'll use 0, 3. Or not 0, 3, what am I saying? 1, 2. So now we can calculate the delta y and delta x of these. So the delta y would be none, because 2 minus 2 is 0. So delta y is 0, and we put that over the change in x. And the change in x here is going to be 1, because 1 minus 0 is 1, right? And we see that the slope is 0. And we could do this for any 2 points on this line, and we'll see that the delta y will always be 0, and because of that, the slope is always going to be 0. So let's do that for this point 2, 2, 2, and we would see that 2 minus 2, 0, 2 minus 1, 1, still going to be 0, right? So we know that the slope of this horizontal line is 0, and actually this rule applies to all horizontal lines, regardless of where they're placed. The slope of a perfectly horizontal line that stays static at that one y coordinate will always be 0, because that line is not increasing. Now, what we have to ask ourselves, what is the equation going to look like? And really, once you know that there is no slope, that means there's no x, right? Because the slope is the m, and then it controls the x, right? The m, it's the coefficient of the x, so to speak. And then that is added to a b, which is the y-intercept. So once you know that the m is 0, then there will be no x. So because the coefficient is 0, there's not going to be any of that variable. If the coefficient was 1, then there would be 1x. So that means the only thing you would have is b. So instead, the equation for a horizontal line would look like y equals b. And we know that b is the y-intercept. In this case, the y-intercept falls at 2. So the real equation of this line would be y equals 2. Right? So really, if you think about it, it makes sense, because for all of the points on this graph, on this line, it's always going to be, the y coordinate is always going to be 2. This line literally describes the entire y coordinate of 2. It stretches out to every point that can have that y coordinate of 2. So it really makes sense that that equation would be called y equals 2. Now, if we look at vertical lines, you'll see something similar, but also something very, very, very different. So let's draw one right here. We'll put it at x equals negative, I'm not sure what that is. We'll see after we draw it. Okay. So this is at -4. And it's really the same rule when it comes to the equation. Because now that the delta x doesn't change, it's only going to be describing one entire x coordinate, and all the points that that graph can have on the x coordinate, that is what that line is describing. So instead of y equals 2, the equation in this case will be x equals -4. I'm going to do it in a different color. So x equals -4. Okay. And if you really want to work this out and do the math, you would see, you could say, ooh, like y equals mx plus b, like we did with the last one. But the thing is, when you try to calculate the slope, you'll find an error. So we're going to do that right now. So delta x in this case, let me erase this. So delta x in this case would be 0 because the x is staying constant, and that goes in the denominator. So already you should be seeing an error here. You can't divide by 0, otherwise it would become undefined. Therefore, this slope, or the slope of this line, becomes undefined, and that is really what vertical lines boil down to. They're undefined. So horizontal slopes will always have that slope of, or sorry, horizontal lines will always have that slope of 0, but vertical lines will have that slope that is undefined. They don't have a slope at all, because it really just stretches infinitely in a straight line from upwards and downwards. So therefore we can't really do this equation and alter it to get x equals -4, because the slope is undefined. So therefore, in order to write an equation for a vertical line, you just look at the coordinate that it occupies, which is in this case -4, and after doing that, you can then sort of write that coordinate in place. So x equals -4. If the vertical line were to be at x equals 1, then you put x equals 1. So yeah, that's basically horizontal and vertical lines in a nutshell. I hope you found this helpful. In the next video, we're gonna go over more about graphing lines and slope, intercepts, things like that. So I'll see you next time.